Let me start first for explain a little bit this new Institute for Experiential AI that started a bit more than a year at Northeastern. You have here the website, ai.northeastern.edu. The idea is to have a single face for AI at the university. The university, it has now 12 campuses in 3 countries. So, for example, there is a campus in London, or maybe some people don't know. And experiential because Northeastern has been always a practical university, like invented the co-op program in the US, and then that was copied in many other places in the world. And we believe that we need to have humans in the loop, although I will say later that I don't like the way that people see it, but we need to have humans involved. And second, we have to handle the right problems. So we have the ethics questions in advance. And sometimes the problem is that we just use more data instead of using better algorithms. So these are the main focuses of what we are doing. So I will talk, so you can find a longer version of this presentation online. So I will talk about 4 different ethical problems that we have today. So automated discrimination, AI phrenology, lack of semantic understanding that then involves ethics, and then the expensive and doubtful use of computing resource. These have a personal bias. There is a 5th one that I usually talk, but I don't have enough time to do it here. But of course, there are many, many more. And then I will discuss like more what are the ethical problems in more generic ways. So too many principles, cultural differences, regulation, and our cognitive biases. And then I will try to briefly, if we have time, to mention what we can do to mitigate all these problems. So let me start with the first, discrimination. And discrimination is mainly used, is based in bias. So you have an algorithm that receives biased data. For me, a model in operation, so a machine learning model in operation is also an algorithm. So it's just a canned algorithm that then is put in operation. And of course, the first bias we have here is that we always think that when we hear bias is something wrong, is something negative. But bias is completely neutral. In fact, information is biased. So random data is not useful. So then doesn't matter the data. Should we ask if the algorithm should be neutral or fair? This is more like the ethical concern. And what happens is that we never ask these questions, and then we get the same bias, and even worse, some cases we get amplified bias. Now, if we amplify the bias in the data, and in a negative way, so let's assume it's a negative bias, then we cannot say that bias is in the data. Even some very famous people in computer science have said that bias is only in the data, but no. I will give you examples that where the bias is in the algorithm, and also the bias is in the feedback loop between the system and the user. And you can check my paper on 2018 on bias on the web. That now is my most downloaded paper. Now, what is being fair? That's a social question. It's a very hard question. So first, computer science shouldn't try to answer this question, but I see some computer scientists trying to answer this question, even without asking the experts. And then here, this cartoon, you have the difference between equality, equity, and justice. Of course, we want justice, but that takes too long. And then what we get is equity, so we do affirmative actions that you can think are positive bias. Now, if you're interested in this problem, I would recommend this documentary that was appeared in 2020, was done by mainly African American women, much better than the social dilemma that was done mainly by Anglo-Saxon American men. And in last year, in 2021, we did an interesting panel with ACM that is available in YouTube, so you can check it, and we discussed this problem in the context of computer science and so on. Now, what is the answer? Well, the answer, as any hard question, is that not always you need to ask these questions, but you must ask these questions if you harm people. And we'll get back to that, to what it means to harm people. Again, that's not computer science, but we can see how proposed regulation express this. Now, how do you solve this problem? So some people have suggested to the bias the input, which will be the best, but sometimes we don't know the bias. So the bias is hidden, so it's not so clear how easy it is to the bias until you find it. Could be some intersectional bias, and there's many intersections you need to check, maybe unfeasible. The second possibility is to tune the algorithm, for example, for ranking bias, which is a typical bias on search engines. There are learning to rank schemes that know about this problem and manage that kind of bias specifically in the way you learn. And finally, you can debias the output, but then you lost already information, because if you are searching in LinkedIn and you get 40 men and 10 women in a search, you cannot apply gender parity because it's already, you lost most of the women. Now, in practice, we never debias. We are always doing mitigation, as I said. We don't know all the biases, so we are just mitigating the ones that we know. Now, the first time, I guess, that this reached the headline news was when ProPublica said that a criminal profiling tool was racist. And then a lot of people tried to validate this result, and the best paper for me that found the real reason is from Cynthia Rudin and collaborators in 2020, that basically found that it was not a racial bias, was an age bias. So there was a bias, but was not on the race, and of course it still was bias. So whenever you have a tool that can be a support tool or automated decision tool, and also even if it's a support tool, there's a cognitive bias to accept this recommendation. So in some sense, you are automating a little bit the decisions of humans. You need to ask two important questions. The first one is a secret algorithm ethical? So basically, should be transparent in all machine learning applications that will decide the life of people. But you have to ask also yourself a different question: is a public algorithm safe? Because if with complete transparency, I can game the system, and for example, I can get free from prison because I knew what to answer to the system. So this is a very nice paper I like to use as an example here. It's by Kleinberg et al., 2018, Human Decisions versus Machine Predictions. And they used this data from the state of New York about basically bails. So the problem of giving bail or not. And if the model was correct, they showed that you were able to decrease the crime rate in 25%, keeping the same prison rate, or decrease the prison rate in 42%, keeping the same crime rate. And worse, if the model was correct, very important, always this is an assumption, basically the judges were freeing half of the most dangerous criminals that, of course, will not come back to court and also will commit other crimes. So this also, I like this example because it's an example of amplified bias. So here, the system is learning from the data, the bias, and amplifies it. So the question is why? That's not clear. That's something that is not explained yet. So I will just give the results. So these are the results of the system. So initially, there's already a systemic bias because the people that reach the court is 49% Black, 33% Hispanic. So both minorities represent 82% of all the people that arrive to court. However, in practice, I put here in red the numbers for the state of New York. They should be only 32%. So the bias is more than double. Now, the judges, you see here the judges are racist because the Black percentage goes to 57%, but in the Hispanic case, they reduce the bias. It goes down to a little bit, maybe because there are more white people there. But in overall, the amount of the minority goes to almost 89%. Now, the model learned to be biased and also to be racist. So increase a bit more the bias towards Blacks, so almost 60%, and decrease a little bit, so also learn the same trend, decrease a little bit, expanded to 30%, but in total was more than 90%, so getting close to 3 times the population. Now, you can play with the model, and for example, if we tailor the model to be as racist as the less racist of the judges, which is the last line here, still you can decrease the crime rate almost to 23% instead of 35%, but being less biased than the original model and also than the original data. So then, based on this example, and also if you see why this is happening, basically it happens because if you take the model as ground truth, then the decisions of the judges are almost like random. So basically, they look like random decisions. They don't have the same relevance that the model has. So here we have then one explanation for that is that human decisions are very noisy. So even for the same type of case, judges are not consistent. So here is kind of a dilemma. What is better? A bias, so still racist, but just in the sense that two people with the same case, they get the same outcome, or a noisy judge that basically, depending on if you go after lunch, you will get worse than if you go before lunch. There are some studies about that. And here I have the examples of the 4 possibilities that are exact, noisy, bias, and bias and noisy. So the good thing about algorithms is that they're only biased. So algorithms are like C, but they are deterministic. They always take the same decisions. But for example, the judges really, they are both noisy and biased. Now, I was using a very interesting paper by Daniel Kahneman published in Harvard Business Review, but last year he published a book on this. It's called Noise, a Flaw in Human Judgment, showing that sometimes noise is even worse than bias for some specific cases. But discrimination has many angles. So, for example, facial recognition, I guess, is the main one. It's the one that is based on the motivation for the coded bias documentary. And when one African American was falsely accused of a crime, then the big companies decided not to sell this. Also, at the ACM US technology policies, we urge a suspension of using these technologies a bit less than 2 years ago, but was too late because the system was already being used. And for example, in September 2020, a second person was falsely accused of a crime because of basically the bias that the quality of recognizing Black people was not so good. There are examples of word embedding, so we'll go fast through this example, but you can see the stereotypes of different ethnic groups that you can learn from text. Then you have the whole world of language models, which is very popular because of GPT-3 and others. And here you see how the number of parameters have grown for hundreds of millions to now basically trillions. So you see it's 4 times bigger in order. But for example, if you take papers that have studied the bias here, you can see that there's an anti-Muslim bias. For example, if you write 2 Muslims walked into A, you will get these 5 completions, and 4 of them are violent. And they analyze the completions for different religions, and basically you find that for Muslims it's 4 times more violent than for Christians, and the less violent are Buddhists and atheists. So basically you get the encoding of people writing news for religions. But it can be much more complicated. For example, I think this example you must know it very well, because when in 2020 the UK predicted the scores to enter university, they discriminated people. Or even one that I really like, I don't know if Daniele knows, this is from Italy, in Bologna, a court found also, this was beginning of 2021, that Deliveroo delivery platform was doing indirect discrimination because basically it was not checking why people couldn't deliver food at night. And this came from the algorithm. This was not discriminating a specific group of people, was discriminating people that could deliver at night. And of course, the model was giving more work at people at night because this is the time there's more demand. So the solution was easy, basically to balance the work between day and night, but to the first designer that was not obvious. As many other things, it's obvious after you know it. So the worst case of discrimination happened in the Netherlands when, after many years of using a system that is not clear if it uses AI or not, but doesn't matter, found that some 26,000 families, accused 26,000 families of being abusing of child care benefits. And at the end, the Supreme Court said that was illegal. Also, it's not ethical because you're looking for fraud in poor people and not in rich people. At the end, 1 year ago, the whole government had to resign. So this is the worst political case of using automated decisions in the world. And these are just a sample of them. If you go to this place, incident database.ai, you will find more than 2,000 cases of issues. Most of them are related to discrimination. Let's go to the second set of problems in pseudoscience. So this is like physiognomy, basically this pseudoscience that tells you that depending on your face or the shape of your brain, basically you will have different personality. And then you see like modern physiognomy in this paper from Kosinski, where using faces, he claims that you can predict sexual orientation. Of course, this is just capturing spiritual correlations, and there are many papers that show the issues with the methodology that he took. But other people have been using this to even worse to detect if you can be a potential criminal. First in China, 2016, and then in the US in 2020. 2021, Kosinski came back again, but now predicting political orientation, 70%. So probably that's only checking if you use too much hair, the haircuts, earrings, and so on. So this is kind of a modern phrenology. So phrenology was even more than physiognomy. It was assuming that people had a different brain. So the structure of the brain was different. And in the 19th century, this was taken to, I guess, to the extreme by Cesare Lombroso, an Italian doctor. And this is his house in Torino, Italy, that you can visit. It's a museum today. Well, he not only believed that the brain was different, he believed that the skull was different. And he collected hundreds of skulls for people that were too poor and no one recovered them in the morgue. And he really believed this because he also left his skeleton, I guess, as the ground truth for a normal person. So this is like he believed all his life this. But it can be worse. So for example, not only Stanford, but MIT in 2019 published a paper that claims that with a piece of your voice, you can predict your face. So I can write my master algorithm on phrenology. So you give me a piece of voice, I produce your face, and from them I can predict your name. Yes, there's a company, Mitra, in the US that has filed this patent that claims that you can predict the name of a person from the face. Again, spurious correlations. It's impossible to predict the name of, for example, adopted child in a different country that will have even different color, skin color, and so on. And then using all the other results, I can know if you're a political opposer, if you're homosexual, or if you're a potential criminal. All these things are non-ethical, but still you see people trying to do these things. The third kind of problem is basically stupidity. You may argue that being stupid is not an ethical problem, but if you are stupid enough to do these models, maybe that's an ethical problem. So in 1976, George Box said all models are wrong, but some are useful. He was talking about the statistical models, but in practice, current machine learning is just very advanced statistical models, so the same is true. We are just when we say model, we are saying that that doesn't capture the whole world. It's a model. Let me give you some examples. Also in December 2020, when Elon Musk said, use Signal, I think it was in January, so sorry, January 2021, when Elon Musk said Signal, some stock market software that was using influencers' data from Twitter saw that Elon Musk said buy stock from this company in Texas and started to buy stock from Signal Advance, and the stock went up in more than 400%. Of course, the company was happy, but a lot of people lost money because he was talking about the chat app, not about this company. But this can be more complicated. For example, in the right, I have an example of adversarial AI, where if you change one pixel, and you see here, for example, in this horse, you have a white pixel, the horse becomes a dog with a 70% confidence. So what the system is learning if with one pixel you can change the prediction. So this is a question that clearly is that they are not learning what we learn. And finally, this example may look funny, but it's not. So I guess some engineer in the US use an English-trained language model and basically decided that Biche, a town in France, was a forbidden word and deleted their web page, their Facebook page. And because there was no human in the loop, the town had to wait, like, I think, 3 weeks to regain the Facebook page. However, if they were using the Facebook page for COVID warnings, of course, this may hurt people. So it's not really funny. So then, because of this, we need to understand the limitations, and this is the ethical part. So we need to be aware of this limitation, because if we're not aware, we do mistakes. So the first one is it's hard to forget or filter what you learn. So when we learn, basically we abstract things in many ways. For example, we see a cat and we know that it's a cat from the beginning. We don't need plenty of images from a cat from different directions. And here I'd like to recall this amazing short story from Borges that is called Funes de Memorios, but was a person that couldn't filter, couldn't forget. So if you find him in the street and ask him what you did in the last hour, you will have to wait until he tells you exactly what happened in the last hour. And that may take longer than an hour, because a split in a second could be more than a second. Second, you cannot learn what is not in the data. For example, there are many problems where situations that are impossible to imagine will happen. And this is what happened, for example, when Uber killed a woman in Arizona, 2018, because the woman crossed in the wrong place at night in a bike, so it was very hard to recognize. And although Uber was the main company accountable for this, they immediately settled with the family of the woman, so they were not sued. And at the end, the state sued the driver that was there, just in case of a problem, because she was looking at the video. She was a poor Hispanic woman, minimum wage. So at the end, the person that was found guilty with 1 year of prison at home was not the real guilty one. Very important here, I have also that data will never capture everything. So data cannot capture the whole context of a problem. So that's why it's a model. It's just a simple understanding of something. So remember, data doesn't capture the reality. And then, I guess it will be clear with these examples, accuracy is not the main thing. I don't care if you are successful 99% of the time. What I want to know is what happens in the 1% of the time that you make a mistake. So this is like, you will never go to an elevator that says works 99%. However, it says doesn't work 1% of the time, but when doesn't work, it stops, then you will enter because you know you will not die. And we haven't reached that level of evaluation. I don't know why we are evaluating still using success instead of using failure. And also, for example, false negatives might be worse than false positives. For example, when you're detecting cancer, a false negative is much worse than a false positive. And finally, if we understand the limitations, then we need to be humble. For example, if you have something with confidence less than, say, 80%, say, I don't know. A smart person will always say, I don't know, when doesn't know. Only a stupid person will try to invent a story. And the final kind of problem is the waste of resources. So this is from green computing. And here I have, again, the same table of language models. But if you see the carbon footprint of training just a simple transformer of 200 million parameters is 57 years of a person. And you spent between $1 and $3 million in power and other things. So this was the paper that triggered that Timmy Gabriel was fired from Google, and then Margaret Mitchell couldn't put her name there, but you see that she still put it, and you can recognize it. But it didn't matter much because arguing that because of ethical reasons, she was also fired in February 2020. Sorry, 21. February 20 of 21. So this is a meta-ethics problem. So, and it's not new. For example, when Google dissolved the AI ethics board after 1 week in 2019, or other companies, and here I have a reference to a paper we wrote because of this that appeared in 2021 too. But this is not new. For example, here you have examples from Amazon, Facebook, the last one, I guess, Spotify. And very few people take the decision of leaving because of ethical reasons. But here I have an example of a person I know, Tim Bray, one of the inventors of XML. He left in July 2020 Amazon because of ethical concerns. Now, I will go very fast here, so we have time for questions. So the second part will be much faster. I will skip a few slides. These are the 7 properties that 2017 ACM proposed to have transparency and accountability. But we need to remember that systems do not need to be perfect because they are learning from us. So, but seems that people expect them to be much better than us. And some other people believe that they can be better than us, so they are praying God that in the future we'll have the singularity or super intelligence and so on. So the Cesar Hidalgo, my countryman, published this book last year, How Humans Judge Machines, where he shows that basically we are harsher on algorithms than on people. I have been doing a taxonomy of many properties of software, and here is my proposed taxonomy that basically has 6 groups: awareness, data provenance, completeness, usability, transparency, and responsibility. These are like the 6 different factors that we need to worry about software. And for example, in completeness and usability, we knew a lot about it, but we know very little yet how to do it in a good way that is transparent or responsible. A person that's working on this is Ben Schneiderman. He just published like 1 month ago his book on human-centered AI. And the problem in the future will be how to use AI to help solve, to do responsible AI, and also how to use AI to combat the evil uses of AI. I will skip this, but basically it has to do with different philosophies that may be better than current ones. Then we have problems on identity, data protection, and privacy. So maybe you know the Article 22 of GDPR, but that article says that I can contest the decision. And in this sense, then if I want to understand how it works, then we need interpretability. If I want to be able to contest, I need to have explainability. And if I want to make sure that things work as intended, then I need to have continuous validation testing. Something important is this this paper that sometimes explanations are worse than no explanation at all, especially in the area of health. Now, there was a case where GDPR is also already put on action, and the reasons were interesting. So basically, the French court found illegal to put cameras in high school because of they didn't have the competence to decide it. They didn't have consent of the people to be recorded in public. That's something that you cannot do. And finally, the solution was not proportional to the problem we're trying to solve. And now we have the EU proposal that is less than almost a year now. And there are several problems here. For example, if you read Article 5, it's very hard to enforce Article 5. Basically, if you present, let's say, an ad of a cake to a diabetic person, that it should be forbidden. But how you will enforce that will be very hard to enforce. So it's not very practical. And the second one, among many other problems, is that the risk, because it's defined on risk is a continuous variable. So basically, we're trying to create categories where there are no categories. So like race, where you put categories on another continuous variable that is skin color. So there are people registering algorithms for transparency. Other people are auditing algorithms to check if they are working okay. Beware, if you audit an algorithm, you are legitimizing its use. Sometimes you shouldn't use algorithms, and then in the case, the audit is very simple. You should say, you shouldn't use an algorithm for this problem. And we are working on responsible AI in our institute, and we have this model of responsible AI that is based on governance, specific assessments of products and projects, and on skills. And of course, even though EU is talking about trustworthy AI, we cannot trust something that doesn't work all the time. So I think it's not the right way to pose this. Imagine that in the 1920s, 1930s, you had trustworthy aviation to convince people that you could trust planes and take planes. So I don't think it's the right way to use it. We shouldn't trust, we shouldn't say that the AI is ethical or just, because these are human traits. So to finish, remember your own biases and ethics. Sadly, the rich people profit this technology and the poor people suffer it. And as already said, algorithms will never be ethical because ethical is for humans. And David Lauer says something that is obvious, but someone has to say it. You cannot have AI ethics without ethics, and this is the main problem today in the big internet companies. Because I'm not worried about artificial intelligence, I worry about real intelligence. So, for example, the stupidity of using English-trained algorithm in France. This is a human decision, it's not a model's fault. And if we don't care about this, then we'll have this joke where both the robot and the computer laughs, not because they kill humans, it's because we kill ourselves, right? We don't even learn not to fight, and we have 24 active words today in the world, although we have a bias to one of them, which is okay, but still a bias. So thank you.